Hello, and welcome to today's episode of Control Intelligence. I'm Mike Bacidore, Editor-in-Chief of Control Design, and your host for today's podcast. In this episode, I'm joined by Matt Mohr, who's the Product Manager at Omron Automation. We'll be talking about enclosures, diversifying consumer needs, labor shortages, and other challenges to manufacture are intensifying by the day across the world. Omron tackles these challenges through three innovations: integrated, intelligent, and interactive. Integrated meaning control evolution, intelligent meaning developing intelligence through ICT, and interactive being human-machine collaboration. This is what it calls the value generation concept, innovative automation. Innovative automation solutions enable anyone to replicate master craftsmanship and create production lines where machines can continue to learn on their own to understand and assist humans. With more than 200,000 products and on-site support capabilities, this is the manufacturing innovation that Omron can deliver. Omron Automation is an industrial automation partner that creates, sells, and services fully integrated automation solutions that include sensing, control, safety, vision, motion, robotics, and more. Omron's 30,000 employees help businesses to solve problems with creativity in more than 110 countries. One of those 30,000 employees is Matt Mohr. He is the product manager at Omron Automation. With more than 10 years of experience in industry, manufacturing, and engineering, he's responsible for the strategic direction of the industrial automation, components, product management, and marketing at Omron. Thanks for joining us today, Matt.
Thank you, Mike. Appreciate the introduction. As you mentioned, my name is Matt Mohr, and I am the product manager for Omron's control panel components, handling products like the power supplies, counters, timers, axial fans, and so on.
Fantastic. So, Matt, let's just jump right into it. Many production facilities are moving components out of the cabinet and onto the production line. Can you talk a little bit about what maybe some of the benefits of that could be?
Sure, yeah, I'd be happy to. That's a great question. So, moving components outside of the control panel isn't necessarily a new concept, but advances in component design have increased the desirability of doing this more recently. So many components do have things like LED or LCD screens or some sort of visual status indicator that provides a lot of information for operators and line workers. Having this information readily available in front of you as opposed to having it locked away in a panel can be very beneficial for production. So this type of visual information provided by modern devices will keep operators informed as far as what's going on with the production process. A good example would be components like counters and timers. So when you use a counter or timer outside of a control cabinet, it can offer an easy, low-cost interface compared to something like an HMI that allows operators to change the timing or the counting or the measurement recipe on the fly without having to write new code for a PLC or a machine controller, which requires them to halt production, or if they're using a counter or timer and they have to open up a cabinet, that's just going to halt production, slow things down, right? So having it mounted outside of the cabinet can be very beneficial there. So modern counters and timers are relatively well designed with simple and easy programming that caters to being mounted outside of a panel nowadays, and so it's not uncommon to find that. Another device that comes to mind would be something like a panel meter, because panel meters have active functions that are similar to counters and timers and a lot of visual indicators to provide important information. So it makes sense to put a panel meter outside of a panel somewhere if you need to monitor that on a regular basis. Thinking about things from a safety perspective, mounting components outside of a traditional control panel will require some extra steps to keep operators and the equipment safe. So first of all, you need to have a remote panel mount box to keep the wiring properly isolated away from the environment, especially if you're in an environment that's a little bit more harsh, right? Another concern is that a lot of products are not designed to be mounted outside of a control panel, and consequently, they don't have an IP rating to protect them from environmental factors. So you wouldn't necessarily want to put it in an open air environment. So again, that goes back to having some sort of remote panel box that you can mount these equipment in, right? And that also may be required from a safety regulations and a protection standpoint to keep people safe, right? So ultimately, any product that has some sort of visual indicator or programmability would lend well to being mounted outside of a panel so operators can keep an eye on the equipment and see what's happening and possibly program that on the fly. This can include, but is not necessarily limited to, things like power supplies, power monitoring products, predictive maintenance equipment, panel meters, and as I mentioned earlier, things like counters and timers, even potentially relays with visual indicators that might need to be actively monitored.
Right. Yeah. Excellent points. Yeah. Especially I liked how you addressed some of the precautions, especially the safety precautions that you needed to take in order to move some of those things out of the cabinet. Getting right back into the cabinet itself, what steps would you recommend someone taking to keep the cabinet design uniform?
Sure. So one of the things that we have, this is an Omron technology, is something called value design for control panels. And it's kind of a methodology that we use when designing all of our control panel components. And so the core idea is having a unified height, width, and depth for all components that goes into the cabinet. And there's a big benefit to that in that it helps optimize the space used and reduces the dead space inside the panel. Basically condensing your components horizontally along the DIN rail so you can fit more components into the same amount of space, basically. And so we have data that shows that you can save up to 50% panel space when you're using value design components from Omron when you compare that to more traditionally designed components that use space a little bit less efficiently.
What about the HMI? Can you talk a little bit about exterior mounted HMI on the cabinet?
Yeah, sure. So HMIs are not my area of expertise, but this is something I have looked into recently, so I can talk on this a little bit. So the improvements made to HMIs recently have been more user-friendly software that is going to allow for more information on the components that you're interfacing with. Modern HMIs have become really highly integrated do-it-all products that even have some control capability. And you can also interface with a modern PLC, which allows operators to call up various different recipes and change production processes quickly to different customer orders, right? And so that's going to allow for minimal downtime and setup time when you're switching over from one customer order to the next, which is really beneficial. And these new features allow for greater flexibility, less downtime, and then that's always welcome in any manufacturing environment. The HMI operator interface is evolving over time to become more powerful and highly integrated tool in the manufacturing environment. So what we expect in the future is that future HMIs are going to continue to add new features, new logic, and new control elements, as well as more advanced user interfaces that provide a wealth of information. So they're just going to become more and more highly integrated and more critical to the manufacturing process.
Right. We're seeing that a lot already with a lot of HMIs, especially combining. We've seen a lot of the HMIs combined with PLCs even that are just, it's been a few years already now, but really starting to become very popular in the marketplace as well. As the cabinet size obviously continues to get smaller as well, minimizing that footprint, how do you design them in order to adjust for those changing thermal conditions?
Sure. So I'm glad you asked that. It's a question that does come up from time to time.
Sure.
So heat inside a control panel is a concern for a lot of people. And improving airflow inside the panel is going to be the key to controlling the temperature of the components in the panel. As I mentioned earlier, one of the things that we have in our value design components is unified component dimensions. And so one of the added benefits of unified component dimensions, aside from just optimizing the space used in the panel, is going to be that you're going to have improved airflow and thermal dissipation, which keeps your components cool and running at optimal temperatures for longer term reliability. Traditionally designed components have varying dimensions, both in height, width, and depth, that can cause turbulence in the airflow through the panel. And as many people know, turbulence impedes thermal dissipation, which leads to inefficient air circulation and potentially hot spots inside the control panel. And heat is definitely one of the biggest enemies to electronic components. So, if you allow your components to run at higher temperatures for extended periods of time, they're going to be very prone to premature failure, which can cause unexpected downtime in production in order to diagnose and replace that equipment, right? And so unified component dimensions helps combat this by maintaining adequate airflow throughout the panel And then additionally, another thing we recommend is that you should always have some sort of active cooling in the panel to get air flowing through there. So that would be axial fans. And we usually recommend at least one axial fan as an intake and one axial fan as an exhaust per panel. However, panels that have more components and are generating more heat, when you have a lot of stuff like power supplies or solid state relays generating heat, may require additional cooling. So this would be determined on kind of a panel by panel basis. But at the very least, we recommend at least one intake, one exhaust fan to get some air and flow through that panel to keep it cooled down.
Great, some sound recommendations there. So with panel design, keeping the components uniform, optimizing the circulation, very helpful ideas. But the most time-consuming part, obviously, is the wire termination. Terminating wires can be a very time-consuming task. Do you have any recommendations for reducing the wiring and termination time?
Yeah, definitely, Mike. So one of the technologies that Omron has is called Push-in Plus. And Push-in Plus is basically a faster method of terminating wires without the use of any tools. And so basically what you can do with a Push-in Plus style terminal is you can insert either a bare wire or a wire with a ferrule on the end of it into the Push-in Plus terminal, and it just clicks into place. It's a very simple process. It's kind of like as easy as snapping a seatbelt, right? And so Push-in Plus technology uses a spring clamp that basically holds the wire firmly in place with about 125 Newton meters of force, which is the equivalent of about 92 foot-pounds of force. And this is greater than what most screw terminals can apply as far as force, and is able to withstand greater levels of heat and vibration without the need for periodic maintenance. So studies show that Push-in Plus wire termination can actually reduce the total amount of time to wire up a panel by up to 60%, which is a pretty significant labor savings when constructing a panel. Yeah. So that's obviously one of the biggest benefits to Push-in Plus. And then something I'd like to mention just on standard screw terminals is that with normal screw terminals, both vibration and heat during operation can cause those terminals to come loose.
Right.
And, loose terminal can create a higher contact resistance, which could reduce the total current going through that connection. And it'll also heat up the terminal. And if it gets loose enough, it could potentially cause issues if unchecked, right? So because of this, standard screw terminals need to be checked and tightened periodically to avoid this. And this type of maintenance is generally very costly from a downtime perspective and from a labor perspective. So, Push-in Plus removes the need to periodically check and retighten these terminals while also offering, some cost savings in the form of labor and an added layer of safety for you. So it's a nice technology to add there. And something I find kind of interesting is that this technology is very widely used across Europe and parts of Asia. It hasn't been widely adopted here in the States, but it is something I do see it being adopted more as we go on throughout this decade here.
Yeah, that would certainly make sense. So what about shipping? During shipping, any number of different types of accidents can occur. Excessive vibration, even so far as dropping a cabinet. What sort of safeguards do you recommend to minimize the effects of any types of accidents?
Sure. Yeah, I'm glad you asked. Actually, we had an example of shipping a cabinet recently where it didn't go well, and basically the packaging was damaged, and when they received it, they had to go ahead and check a lot of the connections and the equipment inside. Unfortunately, there wasn't anything majorly wrong with the panel, but accidents happen, and as you mentioned, there's vibration is an issue. So, usually when a cabinet's done being constructed, it needs to go to the end customer. So you're going to have to ship that, and when you're shipping it, you can experience a lot of vibration when it's being transported on a truck, right? And so Push-in Plus technology is designed to be resistant to vibration. So that's one of the big benefits that it has. And there's also the issue of vibration during normal operation, right? Not just during shipping. So, a lot of industrial automation equipment is going to produce vibration. And if a panel is in the area, it's going to be experiencing that vibration. So, as I mentioned earlier, standard screw terminals are susceptible to coming loose with any kind of vibration, as well as thermal cycling, right? Heating up, cooling down. And so a loose wire connection is something you don't want because it does increase that contact resistance, and higher contact resistance leads to lower current and higher temperatures for that wire connection. And Ultimately, you could even potentially experience a fire or a component failure, which is something I have seen firsthand. So, our push and plus wire terminals are specifically designed to combat this while offering a faster method of terminating the wire. So it's really a twofold benefit there of reducing maintenance, increasing safety, and also a faster method of termination, right? And so, besides using a newer termination method like push in plus, there isn't a lot else you can do to safeguard the wire connections and the equipment inside of a panel when you're transporting it. Basically, if you're not using a push in plus technology, then you're going to be forced to manually check all those wires when that cabinet arrives on site, right, before you connect it all up and start powering it and running it. You're going to want to make sure you double check all those connections and make sure they're properly tightened down. So that's just a common safety practice that has to be done if you're not using a push and plus technology.
Right. So the push and plus technology eliminates the need to do that?
Yeah, I would say generally speaking, it eliminates that need. I've seen some pretty amazing demonstrations where, we connect up some wires to a push and plus terminal, and then people start yanking on that terminal. And man, it takes a lot of strength and generally speaking, you're not going to disconnect the wire. You're going to end up pulling the product off the DIN rail first. Right. So it's on there pretty good. Now, it obviously does have a mechanism to release that requires a tool, a basic type screwdriver type tool. But, once you press down on the release mechanism, the wire comes right out. But, once that spring clamp is attached and locked, that wire is going to stay in there for the most part.
Right. Perfect. Great. Well, I learned quite a bit today, especially about some of the push and plus technology, and especially a few things about the thermal management in the cabinet that I wasn't aware of from before as well. Well, thanks for those very insightful answers and the very valuable information as well. Thanks to our listeners today for joining us on Control Intelligence, the podcast for Control Design Magazine. And thanks, of course, to Matt Mohr of Omron Automation for his insights into enclosures. Thanks for joining us, Matt.
Yeah, thank you, Mike. Thank you very much for having me here. It was a pleasure.
Yes, same here. If you enjoyed this episode of Control Intelligence, don't miss our older episodes and subscribe to find new podcasts in the future. You can find our podcast library at controldesign.com, or you can download all episodes via Apple Podcasts or Google Play.